Alexa, stop. Right, let's get going. Right, good morning everyone, welcome to another lockdown lesson. Just to clarify, we've got 2 more weeks left of lessons for Key Stage 2 and Key Stage 1. There'll be no more GCSE lessons next week though, or any time at all. I've got too much other things to do at home, and a lot of them have gone back to school now. A lot of your year 10s are going back now anyway. So we're going to get on with this lesson today. We're actually going to start pretty much with a game straight away once I've checked you know your coordinates. So to start with, I've got 8 coordinates on this, what's called a Cartesian grid, because the person that invented coordinates was called René Descartes, who was a French philosopher. Rumour has it that it was when he was asleep on his bed and he kept sort of fly buzzing about on the roof, and he was thinking, how can I explain where that fly was on my roof? He was in bed because René Descartes said that he did his best thinking when he was asleep in bed, so he was apparently quite lazy. But he came up with coordinates for maps, as in Cartesian, after his surname, Descartes. So these are the coordinates here. So can you write down the coordinates for each of these letters? Remember, we always go X first and then Y. So we write down our X coordinate and then our Y coordinate for where does it kind of track along. So if you're going to A, you'd go along to 2 there, and then you think about how many you go up. Okay, so let's look at the first one. So if I do another one, let's imagine this spot here. If I put that spot on, okay, that spot there will be 4 along, so it's definitely 4, and then we need to go up 2 spaces, so we'd write comma and 2, and we put the whole thing in brackets, so that would be 4, 2. So can you write down the coordinates for the other letters, please? You can put them on the chat, you can write them at home, it's up to you. You can even just say them, I just want to make sure you know what those are. Okay? And then we're going to use this for a special game of Battleships. Okay, is that right?
Yeah.
Morning Evie and Lily. And hi Elsie as well. Okay, so you're just saying where A is, so I'll just check you've got A. So A, you would need to get to A, you need to go 2 on the x-axis, so it's 2 on the x-axis and 3 on the y-axis. See how those points kind of meet up like that? So 2 and 3, they meet together. So A would be 2 across, 3 up, so it would be 2, 3 like that for A. Do you get anything? Oh, you done them around, didn't you? Yeah, always across first. So you always go across and then up and down, okay? It's really easy to go up first and then across, but we always go across, so the x-axis first. If you think about the alphabet, x comes before y, doesn't it? So it makes sense to go across first, okay? Just try the next one here, try to. Cross first.
Oh.
Yeah, okay, you get used to this while we're doing it, you get used to it. Okay, we're going to get some more practice of this. So what we're going to do, we're going to go to B. We just line them up. So you've got to go to get to B there. You move across first. So you're going across to this one, aren't you? So it's -1. And then you think, where do I need to go down? I need to go down to -3. See, they kind of match up in like an L shape there, in a vertical line and a horizontal line. So B will be -1, -3. C, which way we're going to go first? It's very easy to go 3 first, but we're not going up. We're going across -3 and then up to 2. So this will be -3, 2. D, okay, we're going to go across 4 and then down -2. So this is 4, -2. And E, I think these are really tricky on the line. Okay, E, we're going to go across first. So we're going to go across 1. And then how many do we need to go up, do you think? How many do you think we need to go up here for this one?
0.
0. So we put a 0 in there as well. Those are tricky to get those ones, okay? So those are coordinates. I just thought I'd do that. We haven't done anything like that at all. I thought it'd be good to check on those and keep regular with that. Going to play a really good game now to do with battleships. And you can play this game at home as well. I will give you the sheets to print out and stuff. It's a great game. So this is coordinate battleships. Okay? So it's good. We're going to play boys against girls to see who can get the most points, to see who is the best at everything. Not just battleships. Whoever wins this game is the best at absolutely everything. Obviously this is the only way to test it fairly. So I've got those different ships there. Those shapes are hidden on my grid here. I've got a copy of this grid. You've got to guess where they are. Okay? So if you get a hit, you get a point and you get another go as well. Okay? I'm going to ask you to post where you think it is, and then a G if you're a girl, because it's going to be the girls goes first, then the boys go, and then so on like that. After the first, it just wants to be a hit, I'm going to take the majority answer. So that as soon as I've got 2 the same, I'm going to take that one. So it's really important you all answer if you're a boy, or all answer if you're a girl. So girls, can you start off? So you need to give any coordinate set to guess where one of those ships is. And make sure you put a G next to your answer, just so I know you're a girl.
Ballet, I need my sheet.
You don't need a sheet because I'm going to record it on there. So, okay? So girls, where do you think one of my ships is hiding? So just post any coordinate, and I'm going to take the first one to start with from the girls. Okay, 3-3. So I can tell you that 3-3 is a miss. So I'm going to use a cross and miss. Okay? Boys, your post now. Boys, where do you think the ship might be? (4-0) for the boys. 4-0 is a miss. Okay. Girls, where do you think it is? You can have next go there. Okay, girls, your go. Can you hit one of my ships? We're just going to play till whoever sinks the first ship is going to win the game. Make sure you put a G next to your name for girls. Girls, 4-2. 4-2 is a miss as well. There's plenty of other sectors to go in. Okay, boys. -3-2 is a hit. So boys, you are on a hit now. Okay, so boys, it's your go again. So boys have 1 point. Boys, it's your go again. Okay, so I'm going to let you say now the first 2 pairs that I get. So once 2 people go for the same, I'm going to go for that. What do you reckon, Peter?
Well, it's I can't really make out what shape it could be.
Have a guess then.
So, what one? I say, hold it, and I know it can't be one of the lines.
It could be any of them, couldn't it? Just have a guess. It can go over it. So have a guess at the coordinates. want to do? Take a guess because we're going to go with what the
Negative. Oh, I forgot how to say the corner.
Across and then down. You set the two numbers.
-3 by 2 down.
That's where that one is already. So where's the next one going to be?
-3 by 1 down.
-3. Right. So -3 minus 1. I've got two -3 minus 1s. That is a miss. So it's not there. Right, girls, your go. Can you steal the ship? Which one of those shapes could it be? It's going to be one of those shapes. So girls, your guess now. I've got from girls here, -1, -2. That is a hit. Girls, your go again, and that's a point for the girls. Whoever sinks this ship wins. Girls, another go from you now. That is definitely a hit.
I think I know what this ship is.
You think you know which one it is now, do you? I
Yeah.
think it can be,
It is definitely.
3 different ships, I think. Okay, so girls, another go from you now. Can you work at where this is? -3 from Elsie. I'm afraid that is a miss. Back to the boys. So I think you know which ship it can't be now. Back to the boys. That is a miss. Nice idea.
Well,
I like what you were thinking of
It's
there.
definitely not the rectangle.
Nice idea.
Hold it. Or could it? Just possible. I think I
So
think.
back to the boys. What do you think, dear?
I think that actually there is one -1 by 3 down.
-1, 3 down. Okay. -2, -2. Well, we've got that one. That is definitely a hit. Well done, boys. You got another go.
Oh,
Whoever sinks it wins anyway.
Oh,
So
I know.
which shape can it be? There's got to be
Oh,
one of two
I
shapes,
know.
boys. It's your go again now. Okay, what are you adding to
I
there,
think
dear?
it is -2 by 1 down.
-2. Oh, it could be that one, couldn't it? Yeah. Oh.
I can't win.
It could be 3 shapes.
Well, in yes.
So you got another guess, boys. Another guess, boys. Now. Here says -2, -1. I'm taking the first 2 answers we get.
This is going.
-2, -1 is a miss. Back to the girls. What shape could it be? So it can't be the triangle. Good thinking. It can't be the rectangle. Definitely can't be that one, can it?
Then
It's not the square, so it's one of those 2 shapes.
Oh.
Girls, back to you. Where are we going?
there's no way it can be that one.
-4, -2 for Matthew. That would have been a nice one to go for. I'm taking the first 2 that I get a pair of. Girls, -4, -2. -4, -2 is a miss.
Oh,
It's a miss. Back to the boys.
I think
What
I
do you
know
think,
this.
Theo?
I think it is on the cross in the middle, so no going
That'd be 0.
across. 0. But in fact 0 by going to -2.
So 0, -2. Okay. So back to the boys now. Back to the boys. Got to be close to sinking the ship now. Back to the boys. Who can sink this ship? We've got -1, -1 from the boys there. -1, -1. We've got 2 -1, -1s. That is a hit. Oh, I think the boys can have this now. Jonathan, what do you
I
reckon?
think it's going across.
Oh, so how are you going to say it?
-1 going across by no going up or
So
down.
-1.
0.
Brilliant. So we got so yeah, I'll take that. -1, 0 is the win. Well done, boys. You won that one. So that's game of Battleships. This is a brilliant game to practice coordinates and your problem solving as well. I will get this. I'll put this straight on the. I'll attach it to this at the end of the lesson and put it on the main page as well. It's a great game to play. It is much better than normal Battleships, much more challenging, and it practices your coordinates. Okay, so well done, boys. Boys won again. Boys won the last challenge we did as well. In the, I think that was in the GCSE lesson. Okay, anyway, this is something a bit different. So, we're going to look at functions, okay? A mathematical function, and you might not come across this word before, it's a process you apply to a number that changes it to a different number. So, can you think of any things we do in maths that change a number to make it different? Okay, can you think of anything we do to a number, and you do this all the time? What kind of operations, we call them, do you do to numbers to change them? Okay, we do this all the time, we just don't think about it this way. What do you think, Theo?
Well, to numbers to make them different numbers, we multiply, we fraction, we make them into fractions.
Very good. There's two good functions
take
there.
away.
Okay, let's steal them more, but yeah, so fractions, multiplying are definitely functions. Brilliant. Okay, any other answers? Multiplication or divide, brilliant. Times, adding, fantastic, you got it. So adding, taking fraction things, dividing, those are all operations that you do in a function. So a function machine, okay, I've used the example of the donut machine here. So in a machine, like in a projected thing, certain things happen to the donut. First of all, there'll be mix in the batter machine like that. Then they'll be piped out in the next machine. Then they'll go along to the fryer in the next machine. It looks like they're just coming out the fryer here. Then they go to the icing machine. So a function machine is a way of showing a function. It shows the order which the operation should be carried out. And for once, big maths does not apply. So normally, I've taught you, you always times before you add. Okay? If a function machine says to add first, we add first. So it tells you the order you do something in. Okay? And function machines are great ways to understand how to solve problems and even to look at algebra. So here's an example. We're going to make a function machine for this. So this is based on Tom, who's an Arsenal super fan. Shame you're not supporting Liverpool at the moment. But Arsenal have won 10 games this season. If you get 3 points for a win, then how many points did they get for these games that they won? Okay? How would you work that out? What is the answer? How many points would you get for winning 10 games if you get 3 points for each one? Yep.
Well, you would know that 3 times 10 equals 30. So if you get 3 points for each, it's basically just going to be 3 times 30.
Good. You tied them together, don't you? You do 10 lots of 3, or 3 tens is easy to do. So 10 times 3 is what you would do. Okay, to get 30 points for the wins. So our function machine here, if Arsenal won 10 games this season, if you get 3 points to win, so we will put this number in, they've won 10 games, and we will say times it by 3, and the output is 30. Okay, it's how we work problems out in our head. This is how our heads are working inside. So we put the 10 in, we times it by 3, we get 30. If they won 12 games, we could just put 12 games in, couldn't we, to get 36. So it tells, it's like a formula, it tells us how to work it out all the time. It's a function machine. Okay, now as well as that, Arsenal have drawn 13 games. Now you get 1 point for a draw. So if they've now won 10 games, okay, this is how many points are actually on. If we put 10 in, we do 10 times 3, which is 30. Then we can add their draws on, which gives you an output of 43 points, which is how many points Arsenal have this season, which I'm afraid, Tom, is nowhere near enough to win the league, or even get in Champions League. And I'm a Leicester fan, so I'm glad you're not in the Champions League. Right, so that's a function machine there. So we're going to look at filling in some of these function machines. I'm going to give you your inputs and you work out what the outputs are. Okay, so there's some function machines are. So for each one, can you work out what is going to come out of the function machine at the end? 15 goes in, our function is in the yellow there, what's going to come out? And those ones are double function machines. Okay, so can you work out what's going to come out of each one?
Daddy, please can I get a drink?
Yep. Okay, so it's working out what comes out of each function machine. And this one, you're working out the possible function. What could the function be? If you manage to finish with those, I'm going to give you a super challenge on the board. Down we go space. Okay, do you know what you're doing? Come on. Very difficult one on the board as well.
Alex, please have a little bit of help on that, on
Which
the
question?
fourth one.
The fourth one.
Yeah, with the negative.
Yeah, so 7 take away 9. So think about how much you could take away from 7. And that will get you to 0. And think how much more left you got to go.
Well, 7. If 7 out of 3 equals 10.
Well, let's do 7 take 7 first. That gets you to 0, doesn't it? Yeah. So how much more have you still got to take away? 2. So what 0 take away 2?
Negative 2.
Negative 2. Okay, good. Oh wow, man, that superstar one. I didn't mean to times it by 3. Oh, I should have said times by 4. Sorry guys, use your calculator for that one. That should have said 4 at the beginning. Sorry, the superstar one, even still on that. That should definitely be a 4 because I don't want you to be multiplying decimals. Sorry, so superstar question should say times 4 at the beginning. That should be a bit more easy for you. Still not easy, but doable at least. Okay, right, don't worry if you haven't done all these, just when you get the grips of what these are. So some answers for these ones first. Okay, you should have 22, 32, 6, negative 2. Options for this one, you could have had, well, 2 options. What do you get there for this one?
15.
Take away 15, yeah?
Yeah.
So you could have minus 15. Maybe you chose to, instead of minus 15, you had divided by 4 would have worked as well. Okay, you could say find a quarter of it would work. 10, 25, 33, negative 3 and 21. Okay, it helps to work out this bit, write it out first. 6 times 3 is 18, write the 18 down and take away 8. For this one, so a really long function, sorry I did say times 3 before, but times 4, 4 35s is 14. We're then going to add 7 to it, which is 21. We're then going to take away 4, which is 17. If you square 17, okay, you're going to be doing 17 times 17, which you should be using some sort of grid method for. So that's 100, that is 70, 70 and 49. Add all those bits together, gives you 289. And then you're going to half 289 or divide it by 2, which is going to give you 144.5. So difficult question, really wanted to challenge you on that. Sorry, times by 3 was really mean there. I wanted to square a decimal is very difficult, and really, even in GCSE, they tend to give you a calculator for that anyway. Okay, right, brilliant work on that. So, got here an inverse function question now here. So here we have a birthday cake. Who would have thought maybe it was someone's birthday just yesterday? So cakes cost £7 each. I buy some cakes and spend a total of £42. How much did I... Sorry. So how many cakes did I buy?
How many cakes did my cake? How many cakes did you buy?
How many cakes did I buy altogether? Okay, so how would you work out that one? How would you work out the answer to that question? Cakes cost £7 each. I buy some cakes and spend a total of £42. How many cakes did I buy altogether? How are we working this question out? Nadia?
Well, first, the method I would use was to see how was to times for 7 times, and then do it to the same to 2.
What do you mean, sorry?
So if you times 4 times 7, do 7 times 4 and then do 7 times 2.
Oh, to get
and
to
then,
42.
And then just add
them to, okay, yeah, so you're saying how many 7s going to 42. Okay,
yeah.
Good. So to answer this kind of question, we would be looking at, instead of doing 42 times 7, because if this was a cake question, we know this. Okay? Cakes cost £7 each, so we would times by 7. Okay? And we end up with £42. So the question is, what goes into this function machine? How many cakes did I buy? So instead of timesing by 7, I'm going to work backwards. Okay? What's the opposite of timesing by 7? Dividing by 7. That is called an inverse. So to get from 42 back to the beginning, I'm flipping this function machine round and using the inverse operation to divide by 7 instead. Okay, and that's a really important method. Rather than just guessing and thinking, well, is it this many cakes? Is it this many cakes? To realise that I can do the opposite to that function and go in reverse. It's really important for these kind of questions. So that would be 6 cakes, because 6 times 7 is 42. I know you can work that out. Just make sure, are we multiplying this together or are we dividing, working backwards? So whenever we have a problem that we need to work backwards in, think about going in reverse using the inverse operation. So inverses are opposites. So the opposite of plus is minus. The opposite of times is divide. The opposite of squaring something is square root. That's quite an advanced thing to know about there. But everything has opposites in maths. Well, most things have opposites. So, or inverses we call them. So let's have a look at these functions. Okay, so I've got here this function here, so I want you to work out what goes into the machine. So instead of doing 15 plus 6, we can work backwards. And we could minus 6 to get back to the beginning. 15 minus 6 would be 9. And then suddenly I can solve the problem. Okay, so if we work backwards, it's much quicker than just guessing and seeing what works. So these are called inverse functions. And this is a massive key thing to solving problems in real life. Not just maths, about problems where you've got to work backwards, about money, about time, anything at all, where we do the opposite working backwards. Okay? Think about those double ones. If we're working backwards there, we're going to take away 4, then we're going to divide by 3. Okay, so have a go at these. Definitely do those ones first, and these are the harder ones where you get double functions to work with. Okay? Okay, does that make sense?
Yeah.
Good stuff.
Oh, do you want bingo?
Let's go keep that okay. Which one? So, yeah, just think of it, and the opposite of minus 4 is what?
It's hard.
So we just plus 4 to it, it's not plus minus 4.
Okay.
So instead of doing 7 minus 4, we're going to do 7 plus 4 to get back to it.
Okay.
Okay, we all okay? Yeah, if you manage to finish all those, I'm going to give you one more on board as well. So 5 divided by 2, yeah?
What?
The opposite. What's 5?
No.
What's divided by 2 the same as? Sharing it out, halving it?
But you got, so...
You can halve 5, can't you?
Yeah, you just have to half a 1.
So what's the answer? What's half of 5?
2.5.
Well done, excellent. Okay, right, let's have a look at these answers. Okay, the 5 is a perfect example there of why it's really important to go backwards. Because if you start thinking, what do you times by 2 to get 5? That becomes very difficult. But if you know, well, the opposite of timesing by 2 is dividing by 2, you can find half of 5, and that's a lot easier for us to deal with and get 2.5 or 2.5, whatever you want to write for that one there. Okay, those ones there, another negative one there, and the one on the board. Okay, so if we are going to start with 36, we are going to find the square root of 36, what you square to get 36, which is 6. We're then going to times our 6 by 2, because that's the opposite of dividing by 2, which gives us 12. We are then going to add 4, which gives us 16. Okay, if you work backwards, it's really simple. If you try and think, what could this be, it's very difficult. Okay, so that's what inverse operations are all about. It's about working backwards in your functions. So, just before bingo, we are going to have a look. Well, we've got one question here to do with Elsie. So, Elsie won the bingo last week. This is her adorable dog called Pepper. So every year Elsie buys her dog Pepper some presents for his birthday. Okay, she spends £16 on a doggy massage and then buys her some birthday doggy bone treats, which cost £2 each. This year she spent £38 on Pepper's birthday presents in total. How many doggy bone treats did she buy this year? Okay, so think about your inverse functions. How can we work this one out? By working backwards, doing the opposites. Okay? So think about what you can do first for your inverse operations.
Well, first, I could write down what one doggy bone equal what doggy bone treat costs.
How do you know then?
I'm just writing down so I don't forget how.
Okay. If you can build one of these, if you can make a function machine for it, then we can work back machine for this. Then you can just run it in reverse. So if you can build that function machine with your question mark, what would happen, what would happen, what would happen? Few different answers. This is definitely the hardest question we've had, this one.
I could count in twos to see how many twos go into 38.
You've got the £16 doggy massage as well, haven't you? So what can you do with the £16 first?
Well, I could take away 16.
Brilliant, brilliant there, that's the way, that's what to do first. Excellent work.
So if 6 add 2 equals 8, I'm going to end up with, I still have £22, yeah.
Brilliant.
So if I take away, if I get one doggy bone, that's usually 20, so I need 20 more doggy bones. If I need 10 more doggy bones. So it's 20. So it's 11 doggy bones.
Well done. Try and write down. That's brilliant. Right, so let's look at the function machine. Okay, it's really hard to think about this in your head. Now Theo's got them brilliantly, but if you can just write it down a little bit, it helps. So you would start by doing this. When you buy your doggy bones, you would times it by 2 because they're £2 each. You then need to add on your £16. Okay, and that gives you this year, this gives you a total of £38. So once you've got that, look how simple the question is. We work backwards. So the first thing we do is take away our 16, which if you did that yourself, that's brilliant. So that gives you 22. We then need to see how many 2's go into 22. Divide by 2, which gives us 11 doggy bones. Okay, so 11 was the answer for that. So this thing of going backwards is so important. Even if you don't write out the function machine, this is how our brain should work to solve these puzzles, to do the opposite. So instead of adding on the £16, we needed to take it off first. Okay, and these function machines take a while to write out. So we have a better way of writing them out. We'll use some algebra. Okay, so there's a quicker way to write down these functions. So if we had this one, if this was our function machine, x, which is what we normally use for our input, the number going in, what we're trying to work out. So in that case, it was x was our number of doggy bones. So you put the x in, we add 4, you end up with 12. So in algebra, what we would say is this. We would say this is x plus 4 equals 12. Okay, and if you wanted to find out what x was, instead of plus 4, we'd take away 4, wouldn't we? So we work backwards to find the x. Instead of plussing the 4, we would take away the 4 to get to our input. Okay, so look what I've turned that. That's much quicker to write than that. That's a pain having to draw this out every time, whereas we can just write x plus 4 equals 12. Much easier, isn't it, to write that out? Okay, but I want you to write out the equation, and that's what this is called because it's got an equal sign in. Can you write down the equation for this function machine? Okay? Oh dear.
Oh, okay.
Might have given that away to some of you. Let's see, maybe you didn't see it, maybe you did. Okay, right, so can you write down the equation that goes with that one? So what's the equation? So the x in, can you write down the equation? So what equation does this function machine work? Think about the last one. So the last one I'll put on the board here actually. The last one was this. It was x goes in. We had plus 7 or something like this. Gives you 12. So this would be x plus 7 equals 12. Okay, what would the equation be for that one? You can then solve it as well if you want. So you can work out what x is. So what would the equation be? Can you write it down? So that one, that's an equation there, x plus 7 equals 12.
I was thinking that. Should I write a -2 or should I just write minus them 2?
Minus them 2 is probably best, yeah. That's what it means, yeah.
So it just comes in a proper number?
Yeah, so write it down, that's right. Okay, so what would this one be? X does equal 7. What's the equation?
-2.
What's the equation?
Equals.
Okay, so you just need to write down this.
Equals 7.
X minus 2 equals 5. Okay, and the answer is 7 because you do 5 plus 2 to give you the 7. Okay? Okay, just this one here. If we had x times 6, we do something slightly differently. We write 6x down. And this, for me, if there's one thing you're going to get about algebra early, it's just getting used to this. X means 6 times x. It means times 6. Okay, so if you've got 6x times 6x equals 30, to work out what x is, you're going to do 30 divided by 6. So this little bit there means 6 times whatever x is, whatever you put in. Okay, so that's really important. So the last one, if we have this one, times by 4 plus 7, what equation is this going to give us? So if x goes in, what equation is this going to give us, do you think? We're going to say times it by 4 and then plus 7 and we get an answer of 35. What equation will that give us? I'll give that one there.
x times 4 plus 7 equals 35.
Brilliant, yeah. So how can we write x times 4 down?
So I just write times 4 adds 7.
Mm-hmm.
So 4 times adds 7.
Don't forget your x in there. 4x plus 7, good. Yeah, that's an x, not a time. So 4x plus 7 equals 35. And then to solve this, we are going to take away 7 and then divide by 4.
4x.
So we are going to have a go at something very grown up in maths. We're going to have a go at just solving a few equations like that. Okay, just for a few minutes, and then we're going to play bingo. Okay, so let's just look at the first one. I'm going to do the first one on the board. So if I've got this, if I've got 2x plus 3 equals 9, okay? So my stages, I'm going to work backwards. Remember, this means x, I times it by 2, then plus 3, and I get 9. So I'm going to go backwards. So I'm going to do 9, I'm going to minus 3, and then I'm going to divide by 2. So I'm just flipping these signs around. I'm using the inverse operations. 9 minus 3 is 6. Then 6 divided by 2 equals 3. So x equals 3. Okay? So see if you can solve some of these equations now by using your inverse operations. So start with the 3, do the opposite, do the opposite. We're going backwards in the function machine. Okay, we're going to do this just for about 3 minutes, and then we're going to play bingo. Okay, Theo, does that make sense?
No.
So you're going to start with a 9,
Yeah.
and we're going to work backwards. So this is saying, I think of a number x, I times it by 2 and add 3. So we're going to do the opposite. So instead of adding 3 to the 9, we're going to do what?
Take away 3.
Take away the 3, and instead of timesing by 2,
We're going to
divide by 2. Okay?
So, and then take it away from that one.
That's your answer. Once you've got that, that's just your answer. So 9 take away 3.
9 take away 3 equals 6.
Yeah. And then we're going to have to divide it by 2, aren't we?
Equals 3.
That's it. That's the answer. X equals 3 is your answer.
That's quite easy.
Yeah, it's the same as the function machines.
Yeah. Okay. 2. So 3 add 5. If it's 3 add 5 equals 5 equals 8. Then 5 equals 2.
Okay, have we all got this?
14 take away 2 equals 12. What will 12 be times? 4.
Juice. What about that? Juice or about that? What's that? Oh my goodness. Good.
And then just bring it up together.
Do you want a bottle or juice? Bottle? Yes.
Okay, we all okay?
Where is your bottle? Where is it? Bottle. Bottle. Please. Bottle. I'll get you fresh one.
You got it here?
I've done the third one.
Ready, what are you, the third one?
4
Very good. Yeah, that's brilliant. That's fantastic
That's the
work.
same answer as the second.
Yeah, no, they might be the same. Yeah, they might be the same.
Okay.
Okay, just trying to do one more go.
4.
Oh. Try that one.
Oh,
I'll be really, see, I'm really impressed when you do question 10 in a different lesson as well.
okay. So 20 add 4 equals 24.
Yeah.
But if I divide by dividing 10 by 4, so
Come on, what's 24 divided by 10, remember? Divided by 10 is special.
I'll just go to 2.24.
Yeah, well, you just,
2.4.
very good there, excellent, excellent work.
So 10.
Right guys, let's have a look at some of these. You've done loads to this, but you can see it's all the same though. In terms of the first function machines, it's the exact same as this. This is just a better way of writing your function machines. Okay, so in terms of Elsie, go back to Elsie's dog function. Okay, so Elsie's dog function machine, let's see, what was it? It was £7 a dog treat, so it was x times 7, so 7x plus the doggy massage, which was £18.
Which was 6.
£16 was it, so it was 48, was it in total? So that's, and then she spent £48. So that was Elsie's dog with Pepper the dog. That was what she did there. That was a function machine. So to work out, and this x here is how many cakes, no, how many treats, wasn't it? So what she would need to do with that one, she would take away the 16 to give you 22. It was £38, wasn't it? Take away the 16 to give you 22, and then it was 2, wasn't it? Sorry, 2x. And then she would divide by 2 to give you 11 treats. So these functions are much better written as algebra. And if you can understand how to use algebra for solving problems, for making your own little functions up, your own equations up, you are going to have a huge advantage when you go to high school. Okay? So because it's not just about solving equations, about finding x, it's about real life situations. So this is the equation for Elsie's dog. This is what algebra is all about. It's about solving problems. It's not about letters and just finding missing letters. It's when it means something. Price of the massage, price of the doggy treats, how many treats she got, total she spent. Okay, and being able to use that is such a good thing to be able to do in life. So we are going to play bingo. Well done today. So we want your 9 bingo numbers in there between 1 and 32. Your power animals, you can have monkey, Pikachu or snake today. Remember, if your animal comes up, you can cross off any number on your grid. So can you write down your 9 numbers on your paper at home? Write down your animal, and can you let me know in the chat what they are? We had some people saying they'd won and not posting their numbers on the chat. If your numbers are not on the chat, you are not going to be able to win bingo. Okay, so get your numbers down.
Daddy, I'm afraid that Pikachu is still a little bit sick.
Because we're a bit sick, what do you mean?
Well, because what he spent, like, he got a lot of cold, he's accidentally got a really bad cold.
Can we get a different Pikachu then?
Well,
Possible.
I'm sorry, but I think all of them are on holiday.
Okay, I'll find them. You fill in your numbers, choose your numbers. Choose your lucky numbers, your birthday numbers here.
Okay. I'm gonna have lucky 7. 8. 28. 27. 73. 32.
Oh, it's raining. Oh no.
Oh, Dad, here's a Pika. Why did you want to have holiday in the garbage?
Have you put them on there? Have you put your numbers on?
I probably that
Have you
Pika.
chosen your numbers there?
Yeah. Also got 2 more. 6. 16, 22. I'll show this one.
Right, okay, we've got your numbers posted. Numbers, monkey fan, monkey fan, monkey fan.
I'm a Pikachu fan.
Pikachu today, are we? Okay, Snake, Pikachu. Okay, let's play some bingo. Okay, you ready there?
Yeah.
Okay, first one is 20 plus 6, 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 to kick things off with 20 plus 6. Next one is 2 squared, 2 squared. That means 2 times itself, 2 times 2. Next one is 3 times 2, 3 times 2, 3 times 2. Oh, it's a bad animal. Pika, Pika, Pikachu.
Right, beside the Pika.
Pikachu, cross off your Pika, Pikachu.
Pika.
Cross off any number. If you've chosen Pikachu, cross off any number you want.
Pika, Pika.
Next one.
Pika.
9 take 6. 9 take away 6. 9 take away 6. Don't forget, we are playing for a full house. We need all 9 numbers. When you have 2 left to go, you shout out, shaky, shaky. Make sure you post it in the chat. When you have 1 left to go, stand up and shout, top banana. Okay, next one. 20 plus 8, 20 plus 8. 20 plus 8, 20 plus 8. 30 minus 7, 30 minus 7. 30 minus 7. 3 times 5, 3 times 5. 3 times 5, 3 times 5, 3 times 5. 6 times 2, 6 times 2, 6 times 2. 6 times 2. 15 minus 2. 15 minus 2. How are you doing? That's not too bad. 15 minus 2. Double 8. Double 8. 30 plus 1. 30 plus 1. 30 plus 1. 22 minus 2. 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 5 plus 6. 5 plus 6. 5 plus 6. 5 plus 6. And it's lucky number 4 plus 3. 4 plus 3. 4 plus 3. I thought you must have put down that one, Theo. 4 plus 3. 5 fives. 5 times 5. 5 times 5. 5 times 5. Anyone getting close? Anyone getting close? Oh, we got a shaky, shaky. We got a shaky, shaky. Shaky, shaky already. Shaky, shaky. Shaky, shaky from Lily. 11 times 2, double 11, double 11, double 11, double 11. And we've got double 12 as well. Double 12, double 12. Double top banana, we got a top banana, we got a top banana. Top banana.
Who's the top banana from?
I don't know who that is. And 20 plus 9. 20 plus 9. 20 plus 9. Playing for 2 winners. 2 winners. 20 plus 9. 20 plus 9. We've got 10 plus 4. 10 plus 4. 10 plus 4. 10 plus 4. And 10 plus 7. 10 plus 7. 10 plus 7. Another shaky, shaky as well. Shaky, shaky for 2 left. 4 times 2. 4 times 2. 4 times 2. 4 times 2. 4 divided by 2. 4 divided by 2. 4 divided by 2. Shaky, shaky from Evie, and another shaky, shaky. It's getting close. There's not many numbers left. No, not many numbers left, guys. 30 plus 2. 30 plus 2. Shaky, shaky from Matthew, and a top banana. 30 plus 2. How many you got left, Theo?
3.
3 left. Oh, it's on its own. It's number 1, number 1, number 1. Number 1. Shaky, shaky from James as well. It's a big shaky, shaky. Okay, we've got bingo! We got one winner. We got one winner. One bingo, one bingo. 7 times 3. 7 times 3. We got one winner. Congratulations. Is that a top banana for Matthew as well? Top banana for Matthew. 7 times 3. 7 times 3. It's a power animal. Snakey today. The snake is out. The snake is out. That may well give us some winners for the snake. Yes, we have bingos. We have bingos. Right, guys. Okay, that is the end of the lesson. Just to confirm, there will be 2 more weeks worth of lessons, but no more GCSE ones. So we're back to Tuesday and Thursday next week for Key Stage 1, Key Stage 2, and the week after. And the week after that, there's going to be one night where we're going to do a quiz and a few awards giving out just to celebrate the end. That's for the whole families as well. That'll be in the evening. Okay? So thank you very much. Have a great weekend and well done. Everyone getting a bingo now. Okay, well done everyone.